All right, so don't get confused with what I drew the line under here. Everything up here is about question 33. What we're fixing to do now is about question 34. All right, so this is dealing with slope of a problem. And so slope, we have defined 3 times in these as rise over run. Okay? Rise represents the change in y over change in x. How do you measure how much something changes? How do you measure how much something changes? If you wore a size 8 last year in a shoe and now you wear a 10, how much did your shoe size increase by? 2. How did you know that? It went, well, how did you know it was 2 though?
Because the difference is 2.
The difference is 2. So change is measured by difference, which we went to the arithmetic sequence one earlier and we called that a common difference. So arithmetic and linear are the same thing. Okay, so now I need to see the change in y over the change in x, and so here are my y values, -4 and 7, and here are my x values. So if I asked you how much did it change from 7 to -4, how much did it change by? The amount of change in y over the amount of change in x. If I am at -4 right now, and I came from 7, all right, you said 11. Well, 11 would make that 18, wouldn't it? But it went down, so it has to be what? -11, right? Because it went down to -4. All right? The other one is I'm at -6 and I was at -4. So did I go up or backwards? I went backwards, -2. Now here's mathematically what it looks like. I am at -6. I went backwards to -4, and that is -2. Right? Now, as I compare these two, they react to each other. So what are those two negatives going to do? So it's going to be 11 over 2. Which one is that one? Very good. All right, we will shut it down there today.